Hello everyone. In this video, we are going to see how we can implement round-robin CPU scheduling algorithm using a C++ program. And we will see that this program will work for the same or the different arrival time. That means if the process arrived at the same time or if they are arriving at the different times, the program will work on both the type of examples. So let's start. So here you can see we have taken an example to understand our round-robin algorithm. So we have the three processes with their arrival times 0, 1, 3 and their CPU burst time is 5, 7, so. So we have not taken IO burst time into consideration. This is the CPU burst time. Now this is the Gantt chart according to the round-robin CPU scheduling algorithm for this example. So just for recall, round-robin is a preemptive algorithm. So what is preemptive algorithm? So let's say this is the ready queue and this is CPU. And let's say process P1 is executing currently on the CPU. Let's say some another process comes inside the ready queue. Then this P2 can ask this P1 to leave the CPU. Okay. And then P1 has to come again to the ready queue if it has not completed its CPU burst time, and P2 will run. So this is preemptive algorithm, means a process inside the ready queue can ask the currently executing process on the CPU to leave this CPU. Okay. So we have the shortest remaining time first, round robin, and the priority algorithm. These are some of the examples of the preemptive algorithm. Now, on what basis this process which is inside the ready queue can ask the currently executing process to leave the CPU? So there is a concept of time quanta in round robin algorithm. So round robin says that each of the process which is coming inside the system, it will be associated with a time quanta. That means round robin algorithm says each process, let's say it will run for a particular unit of time, that is called time quanta. So let's say if round robin algorithm is applied on the scheduler and time quanta is set to 2 milliseconds, that means each process will execute on the CPU for 2 milliseconds. Okay. And after that, it has to leave the CPU. Okay. So for example, we have P1 and P2. Okay. And let's say P2 starts. So P2 will run for 2 milliseconds. Okay. And after that, this P2 has to come back. Okay. This P2 has to come back and it has to sit inside the ready queue. Then the next process, that is P1, it will get the CPU. Okay. And it will get the CPU, it will execute. Okay. After 2 milliseconds, it will again come back here. Okay. And again, P2 will get the CPU. So in this way, all the other processes will also get the CPU turn by turn after TQ unit of time. So this was just for recall. I hope you have recalled. And if you have not recalled, you can watch the video on the round robin CPU scheduling algorithm in the operating system playlist. So that is the prerequisite to understand this program, that you must watch this video, that how actually the round robin algorithm work, and you should solve some of the numerical based on this round robin to understand this program better. Okay. So I'll come back to this Gantt chart later. So actually in this program of the round robin, we have to take the process IDs, arrival time and burst time as an input from the user. And then we have to print these as the output. That is turnaround time, waiting time, response time, throughput, and CPU utilization percentage. And these are the formula that we have discussed in the previous videos. Okay. So here the one important thing to note is the response time is equal to the start time of that particular process minus its arrival time. Okay. So for example, here you can see if you are calculating the response time, let's say of P3. Okay. So what is the start time of the process? At what time this P3 has got the CPU for the first time? At 6, right? And what is the arrival time of this P3? Arrival time of P3 is 3. That is somewhere here. So 6 minus 3, it will be 3. So that is the response time. So in non-preemptive algorithm, the response time is calculated this way. And in the preemptive algorithm, okay, you can do this way also. And in non-preemptive algorithm like FCFS, the response time is actually equal to the waiting time. Okay. So either you can use this formula also in the non-preemptive, or you can just say RT equal to WT. So this was the important thing for the response time you have to take care in the preemptive algorithm. Now the another thing that you have to remember in the round robin program is the input can be given in the unsorted manner. For example, here this P2 has arrived at 1, but P1 has arrived at 0. That means P1 is the first process that has arrived, but it is at the second position, or you can say 0, 1, 2. This is at the 1th position. So actually, as we know, the round robin algorithm says that the process which has arrived for the first time, it will get particular unit of time, that is time quanta, then the next process, then the next process, and in this way, in the round fashion, all the process will get the TQ amount of time on the CPU and they will get completed, right? But for this thing to implement, we have to sort the processes based on their arrival time. So that means if we sort this data based on the arrival time, then you can see P1 has come to the 0th position, then P2, then P3, right? So this is the first process which arrived at the 0, P2 arrived at 1, and P3 arrived at 3 unit of time. Okay, so this way you have to first sort the data or this input based on the arrival time. Then you can proceed with the round robin algorithm. So I have written the completion time, turnaround time, waiting time, and response time also of all these processes so that you can later verify with your program output. Okay, so now let's proceed. So here is our algorithm for the round robin. So these are the steps that we will follow in implementing our program for the round robin. So I'll tell you the pseudocode for all these steps, but here just let's have some brief idea that how our round robin algorithm will work. Okay, and the depth idea we will see in the later in the video. Okay, so first we have to take the input from the user. Okay, so what will be the input? Input will be the total number of processes, then their arrival times, then their CPU burst time, right? And the last thing that you have to ask from the user is time quanta. Okay, that is TQ, that is the amount of time for which a particular process has to run on the CPU, and after which time that process will leave the CPU. Okay, so next thing is you have to sort the processes based on their arrival time in increasing order, as we have discussed just in the video. Next thing is you have to take a ready queue explicitly. Okay, you have to take a ready queue, or you can say you have to implement or you have to simulate the ready queue that we normally discuss in our round robin or any of the algorithm. Okay, so how you can simulate a ready queue inside your program? So you can simply take you can say array, okay, to implement a queue, or you can just use any of the STL library. If you are using the C++ program, okay, then you can use the queue from the STL library. Okay, so that is up to the language actually used. Okay, so we will take a simply queue which will work on the first in first out principle. That means let's say P1 arrived at some particular amount of time and P2 also arrived. Okay, let's say both are arriving at 0. So first, whatever process is inside the ready queue, okay, that will be given to the CPU. Okay, and after that, what will happen? P1 comes here, okay, according to round robin. Then P2 will be given, okay, because this is the next process inside this queue. Okay, P2 will be given, and after 2 millisecond, okay, let's say time contact 2 millisecond, P2 will come here. Okay, now again P1 will be given the CPU because it is the next process inside this ready queue. Okay, so in this way the processes will be given to the CPU based on their manner in which they have been placed inside this queue. So this is a first in first out queue. Okay, so you have to take a queue in this way and you have to implement this way. After that, what you have to do, this is this step that I have already discussed. Whatever processes you are getting here, okay, for example, you are getting processes something like P1, P2 and P3, and this is 0, 1, 2. So first you will put this P1 inside your queue, this queue, then you will put P2, then you will put P3. Okay, so firstly what you have to do, just take out the first process and put inside the queue. Okay, and what you have to take, you have to take another array, you can say a visited array, okay, which will just tell us ki, okay, whether particular process has been put inside this queue or not. Okay, if particular process has put inside this queue, then we will say that particular process will have the visited array index as 1. Okay, that we will see, okay, later in the video. Let's say P2 and P3 have not been placed inside this FIFO queue, they will be false, or you can say they will be 0, or they can be something like FALSC. Okay, we will see. So this is just for tracking which process has been placed inside this queue. Okay, we will take a current time variable to track the time, and after that this is the code that we will see in the later in the video. Okay, so we will directly see the pseudocode so that you can understand later these steps in a better way. Now before going further, let me ask you a question. How we can group the information of a process? So you can see with the process we have many information. For example, their arrival time, their burst time, their completion time also that we are going to calculate, the turnaround time, waiting time, and the response time. So for each process we are having these information, right? So how we can store or how we can group these information so that we can later on recover or later on we can fetch this information of the process in a better way. Okay, so what thing we will be using inside our coding? So there are actually two ways in which we can group the information of a process. One is we can use the separate arrays for the arrival time and the CPU burst time that we have discussed in the previous videos also. So what we can do, we can take arrival time array. Okay, this array will be storing the arrival time of each of the processes. For the process 0, here arrival time will be stored. For the process 1, arrival time will be stored here, and so on. The same thing we can do to store the burst time also. Okay, so this bit is storing the CPU burst time of each of the process. Now the same way we can take the completion time array, we can take the turnaround time array, and so on. Okay, so we can take as many arrays as we need. But what we want actually, but there is a better way also to group the information. Okay, because the arrival time, the burst time, the completion time, turnaround time, all the information, they are like associated with a particular process or with each process. So all these related information can be structured in a better way. And what is that better way? That is, we can use the structure. We can store PID, arrival time, burst time, and all the information of a process inside a structure. So here the structure name is process struct. And what we have done is we have taken a array of structure. So here you can say this PS is an array of structure which is storing 100 datas. Okay, or you can say 100 boxes are there. So PS0, PS1 to PSN-1 it can be there. Okay, if we are talking about the n processes. So each box will have the PID, arrival time, burst time, completion time, and so on, all this information, right? So this is the better way that we can use to group the information of the processes. Okay, so this we will use inside our coding. Okay, now let's proceed forward. So let's see how we can scan the number of process, arrival time, CPU burst time, time quanta from the user. So here you can see for inputting the arrival time, we have taken a for loop. For inputting the burst time, we have taken a loop. Okay, and how we can scan the number of processes? We can just use C in N. Okay, if we are talking about the C++ program. For the C program, you can just use the scanf. Okay, now here we are asking the arrival time for each of the process from I equal to 0 to n-1 process. Okay, and all the arrival time they are going inside the PS of I.at. So PS of 0.at, PS of 1.at, and so on. Along with we are scanning or we are initializing this PID variable also. So we are saying okay, the PID of this process will be equal to I. That is, if I is 0, this will be 0. If I is 1, this will be 1. In the same way, this will be 2, and so on. After scanning arrival time, the same way we are asking for the burst time inside this pi.bt variable. Okay, so inside this bt variable, all the burst time of the process will be going from I equal to 0 to n-1. And along with what we are doing, we are actually storing all these burst time inside a new array that is called bt underscore remaining, and this bt underscore remaining array is outside of the structure. Okay, so we are saying okay, for the 0th process its burst time should be copied inside the new array remaining array. So we have taken a new array, and the burst time, let's say here it is 2, here it is 3, here it is 5. So 2 will be copied here, 3 will be copied here, 5 will be copied here. So this is actually a duplicate copy of this bt, okay, for each of the process. And we are using this bt underscore remaining, we'll see later in the video, and the same array we have used in the shortest remaining time first algorithm also. Okay, so this is the same array that we have used there also. Okay, but we'll see later in the video. And the role of all these variables we'll see later in the video: the current time, completed, eq, and visited array. So after sorting the processes based on the arrival time, okay, here we will write a comparator function which will sort the processes based on their arrival time. That we will see when we will code actually. Okay, so for the time being, let's assume that we have sorted the data or the process based on their arrival time. Now we have to do the processing on this input, okay, or on this array, okay, so that we can compute all the things like turnaround time, waiting time, and throughput. Okay, So let's see how we have to do the processing on this data. That is the main part of the round robin algorithm. So this is the main part of the round robin CPU scheduling algorithm. So here you can see we have taken some of the arrays like visited array. Okay. So as you have seen in the previous slide, that visited array will be false. So here you can see visited array is false, and the completed variable and the current time, they both are initialized to 0. Okay. So here you can see I have used the completed variable. I have used the current time also. Both are initialized as 0. Now, if we start with the algorithm, so here you can see we are first saying put the first process inside the queue. Okay. That means whatever process has arrived for the first time inside the, you can say, system, that process should be put inside this queue. Okay, so we can implement queue in any of the way. You can use the C++ STL, or you can use the array to implement this queue. Okay, that we are not so much concerned about here. We will see later in the program. So this is the structure box 0, this is the structure box 1, and this is the structure box 2. So these are the indexes of that structure, that is PS structure. Okay. So what we are saying, inside the queue, we do not have to put any PIDs or the arrival time. Inside the queue, we have to put the indexes of the processes. So if we are saying we are putting P1 inside the queue, that means we are putting the is index, that is 0. Okay. So inside the queue, let's see here, we are putting 0. Okay, this is the index, that is 0. So I am putting here, okay, just to simulate. Okay, that is, this is the first process inside the queue. Okay, you can use here. Okay, that we are just understanding for the diagram purpose. So I am just putting here, then I will put the next index here. Okay, now for this process I am saying the visited of 0 is true. Okay, so the first process will be actually at the 0th index. I have put inside this queue, so I will be saying keep this visited box of this 0th process which I put inside this queue as true. Okay, so this is true. So actually initially all will be false. You can see, okay, all will be false. By this line, this 0th process, this particular row or column box, this is made true because it has been put inside the ready queue now. Okay, now we'll start with the processing. Okay, so for the first process we are changing the visited here, but for the rest of the processes we will be changing the visited inside this algorithm or inside this code. Okay, so here you can see I have changed the visited array also here for the other processes. Okay, so let's see. Now we are saying till the time all the processes are not completed. Okay, so here you can see while completed not equal to n. So for our example, the value of n will be 3 because we have 3 processes. Completed initially is 0. So completed is telling me that how many processes have been completed till now. So no process have been completed, so it is 0. Okay, so while completed is not equal to 3, I am doing all these things, this if, this else, this for, and this all these things. Okay, and here my while loop is ending. So this is the whole structure, and inside this I am checking various conditions. Okay, and it's like I am executing on the CPU. Okay, here I am saying TQ and all these things. So let's see. So what we have to do, we have taken a variable called start time. Start time will be telling me that at what particular point of time a particular process has been started to execute on the CPU. Okay, that start time is being told by this start variable. Okay, so current time, it will be telling me that what is the current time at particular point of time. Okay, so it's like let's say if I see a watch, currently it is 2 o'clock, so current time will be telling me 2 o'clock. Okay, then if at particular unit of time, it's like the watch is showing me 4, so current time will be showing me 4. Okay, we can see the first process is this P1. Okay, that is here. Okay, so I'll write P1 also. Okay, just to remember. Okay, now what we have to do, we have to set the start time of this P1. So if I make the Gantt chart, so P1 will be starting at 0, right? So this start time should take this 0 inside it. So here you can see what I'm saying. Okay, please check the bus time of this PS array for this particular variable. Okay, so actually this index is actually this 0 that we have put inside the queue. Okay, so this index currently is 0. okay, this 0 number, right? So for this bus time is 5. And the next thing is check the remaining bus time of this process, that is P1. So we have a remaining array, okay, or you can say bt underscore remaining, that we have seen, right? So here you can see the bt underscore remaining array is this, and this will have all the data of the bus time copied. Here we are saying, okay, this bus time and this remaining bus time of this P1, this first process, is equal. Yes, this is equal. So we are saying, okay, this process has arrived for the first time, so set its start time. How we are setting the start time? We are saying take the maximum of the arrival time and the current time, okay? So for the time being, the arrival time is also 0 of this process and the current time is also 0. So it will be 0, 0, maximum is 0. So the start time will be initialized as 0, okay, for this P1, okay? So this is the start time, right? Now the current time will be equal to start time only because it is 0 only. Now after setting the start time, we have to execute the process on the CPU, right? So how we can simulate this in our coding? So this is the part that we are saying, okay, now execute the process on the CPU. And when the process will be executing on the CPU, what things will happen? Its time will be reduced, okay? That means the remaining array will be changed, okay? We will not change this CPU bus time column, okay? We will be changing always bus time remaining, and we will be using this to compute, okay, what is the remaining time for the next time for a particular process, okay? So we will be decrementing this remaining array only. So it can happen, here you can see, for example, time quanta is 2 milliseconds, let's say. So this 5, that is the actual bus time, it can be greater than this TQ, right? Okay, or you can say this remaining. It can also happen that for a particular process, let's say for P2, instead of 7 we are having 2, right? The bus time is given as the 2, that is it can be equal to the TQ. It can also happen that for a particular process, this bus time that is given to us, it can be lesser than this TQ. For example, instead of 2, the bus time can be given as 1 also, okay? So there can be 3 situations, right? So let's say if P1 go to the CPU, okay, and it's complete its TQ amount of time, that is 2 milliseconds is completed, then how much time is left in the future for this P1? It will be 3. 5 minus 2, 3, right? If P2 is having, let's say, the bus time as 2 only, okay, then P2 will come here and it will execute, and after that its remaining time will be 0, that is it will not execute in the future because it need 2 unit and it has completed 2 unit. P2 has the bus time as 1. P2 will come here and it will complete itself before the TQ amount of time because its bus time will be 1, okay? Then it will also complete, okay? And the remaining array will have what value? If the CPU bus time for the P1 is given as 1, then what will be inside the BT underscore remaining after P2 has been completed? It will have 0, okay? So 0 can come inside this BT underscore remaining in what situation? When a particular process has completed itself completely. So here you can see, we are saying, okay, the remaining bus time of a particular process, it can be greater than your TQ time, or it can be equal to TQ, or it can be lesser than TQ. And based on this, we are going forward. So here you can see the same thing we can write this way also, okay? So for example, for the first, this is 5, okay? And what is the value of TQ? It is, let's say, 2. So 5 is greater than 2, that is BT underscore remaining is this 5. It is greater than 2. Yes, 5 is greater than 2. Now to know that whether a particular process after executing on the CPU, it will complete itself fully, or there will be some amount of time left in the future also for that particular process. To know that thing, what we are saying, we are just changing this. We are pre-assuming or pre-calculating the things. We are saying, okay, just calculate 5 minus 2. It will be 3, and 3 is greater than 0. It means a particular process when execute on the CPU, it will be left with some amount of time in the future also to run, right? So 5 minus 2, it is 3. 3 is greater than 0. It means come here and just subtract TQ amount of time from the remaining array. That is 5 minus 2. It will be 3. So BT underscore remaining array is changed to 3. Okay, that means we have run the process on the CPU. Now current time will be changed to what? So this P1 has been run for the 2 unit amount of time. So it will be 2. So this is the current time. So 0 plus 2, okay, or you can say current time plus TQ. Now this process has not been completed, so we'll not come to the else part, because else part will be saying, okay, when a particular process has been completed fully, then do all these things and find its completion time and everything, okay, but we will not come to else part. Okay, now after executing this P1, okay, after executing this P1, what we have to do now, we have to check whether from this list new process can come inside the ready queue. Okay, so here we are saying ki, okay, check which process has the remaining bus time as greater than 0. That means those processes are still left to run, and we have to see whether those processes have not come inside this ready queue even for the one time. So that we will be checking using the visited array. Okay, so visited box for that particular process will be 0, okay, or you can say false. Okay, and we have to see till current point of time only. So we do not have to scan the whole array. Okay, we have to just see for the 2 unit amount of time, that is the current time we have to see. So till 2 o'clock, what are the process that have arrived? So here we can see only P2 is the new process that has arrived till 2 o'clock. Okay, and for this visited array is false. So we will be saying, okay, we are saying P2. So here you are saying add that process in the queue, and inside the queue we are actually taking the index, that is 1. So I will be just saying 1. Okay, this P2 is just for your understanding, otherwise we will be storing 1. Okay, and this is actually gone from this queue, and we will be saying, okay, we have taken this inside this queue, so visited of this particular P2 will be true. Now after doing this thing, what we are saying, okay, again check, is there any other process till 2 o'clock? So the next process P3 that has arrived at 3. Okay, so this condition will be false because till 2 o'clock this process has not arrived. So again we will be checking for all the other processes. So all the process till 2 o'clock will be put inside this queue, and for visited array we will be marking them as true. Okay, now after this we are coming here. Okay, so this is the for loop that has been completed. Now what this code is checking, see, from this list we have taken the processes. Now this P1 may be left to run, right? This P1 may not have been completed till now. Now in this example here you can see it has 3 unit of time remaining. So what we have to do, we have to say P1 you can also come here. So this code is saying P1 you come here. Okay, so P1 means the index of that particular process, that is 0. Okay, but I'll not be talking more about this index. I will be just putting P1, P2, P3. Okay, so P1 has come here. So first we have put the process from this table here, then we have taken the process from the queue. So this you have to remember, you cannot switch this thing here and this thing here. If you do this thing, your algorithm may give some another answers. So in most of the books, this is the thing that we have to do. First you have to take the process from here, and then you have to take the process from the CPU if it is still left to run. Now after this is the thing that we'll see in the next page, that is what if there are no process inside this queue. Okay, then what we have to do, we'll see later in this video. Okay, so now you can see P2 and P1 has come. Okay, now you will again go here. So what is the next process inside this queue? That is the P2. So now P2 will run. Okay, so what we will do here, we will keep completed is not equal to n. Okay, come here, just check for this P2, that is the index number 1. Okay, for this P2 the bus time and the remaining time is equal. Yes, 7 and 7 is equal. That means we have to set the start time. Okay, so here you can see we will be setting the start time of the P2 equal to what? See, P2 is starting at 2, so it will be 2. Current time is 2. That means from this part, this current time will be going to the start time. So here you can see the current time is 2. What is the arrival time of this P2? 1. What is the maximum? 2. So current time will be going to the start time. Okay, so you do not take the minimum here, otherwise it will be wrong. So we have to take this maximum. Okay, although it has arrived at 1, but we have to take the 2. That's why I'm taking the maximum. So start time of P2 is 2. Current time will be set to this start time only. Now come here and just see, you execute it on the CPU. So here you have to see 7 minus TQ. 7 minus TQ is, that is 7 minus 2, it will be 5. 5 is greater than 0. Okay, so come here, just remaining is subtracted, that is 5. Current time will be changed to what? So 2 plus 2, that is TQ amount of time we have run on the CPU. So 2 plus 2, 4. So 4. So here you can see current time was 2. 2 plus 2, that is the TQ, 4. Okay, so this is adding. So you can say this is like C equal to C. C is current time. Okay, current time plus this TQ. So that's why we are saying 2 plus 2, 4. Okay. Now after this, just come here. Okay. And because P2 is also not completed, we are not computing here. Now just see what are the new process that has arrived till 4. Okay. From here. So this is checking that thing. So till 4, only P3 is the new process that has arrived. Okay. These are not the new process because for P1 and P2, these are true. So this P3 will be submitted here. Okay. And there are no new process. Okay. So P3 is the only process. After this, for loop will be over. And now come here. Just see this process that is P2 was running here. P2 can come here or not. Yes, P2 can come here. Because why? Because its remaining time is still greater than 0. So here we will be actually checking if bt underscore remaining is greater than 0 for that particular process, or you can say for that index number process. Okay. So yes, it is greater than 0. So now we will take P2 here. Okay, inside this queue. So after doing this thing, just again go here, and this way we will be saying again for the next process, that is P1, just see the bus time and the remaining time, they are equal. No, 5 and 3, they are not equal. So we are not saying okay, just initialize its start time again. We do not have to do this thing. Just come here and just see execute on the CPU. So P1 will be going here. Okay, so 3 minus 2, it will be 1. Okay, so it is 1. Now current time will be 4 plus 2, that is 6. 4 plus 2, 6. So this is P1 here. Now again we'll come here. Okay, and we will add the new process. There are no new process. Okay, so this for loop will keep on going, but there will be no new process added to the queue. Okay, now we'll see okay whether we have to add this P2 to this queue or not. Yes, we have to add. Why? Because its remaining time is greater than 0. So we will be adding here. Okay, so this way we have added P1 again. Okay, so P1 is not here, right? Again we will be going, and this way now P3 will be put on the CPU. Okay, so here you can see completed is still 0. Now for P3 you can see that the remaining and the bus time both are equal, 4 and 4, because it is starting for the first time. So for P4 this will be the current time, right? So, or you can say the start time. Okay, so the current time was previously 6, right, when P1 was completed. Here you can see this, when P1 was completed, this P1 was completed, we have made the current time as 6. Okay, so when we come again for this P3, we said okay, initialize start time, current time is 6, arrival time is 3. Okay, start time will be 6, and the current time will be again set to this 6. Okay, come here, and now just see 4 minus 2, it will be 2. Okay, this is greater than 0. So you change the remaining now and set its current time will be plus 2, that is 6 plus 8. Okay, so this is 8. Now again come here, see new process has come. No new process has come inside this table. Okay, so this for loop will not add anything inside the table. Now see, this P3 was running on the CPU. Can it be added again to the queue? Yes. Why? Because it still has to run for the 2 unit amount of time. So P3 will come here. Will come here. Okay, and what we have to do? We have to take the index of this P2. Okay, that means this one. Okay, so we'll see for P2, 7 and 5 both are not equal, so we'll not come inside this heap, we'll come here. Okay, so 5 minus 2, it is 3. Okay, that means this process has to run due to this code. Okay, so come here and just say 5 minus 2, 3. So we will run this P2. Okay, so this P2 is running here. Okay, you have to take care. So 8 plus 2, 10. So this current time is set to 10, remaining has been changed to 3, right? So after this thing, we again come here. This loop will actually not run. Okay, after this time this will not run because there are no new process that can be added. Okay, so for any point of time this loop will be like not running. Now we will be adding this P2 again. Why? Because it has 3 unit of time still left. So we will be changing and we will be adding P2. We'll be again going back and we'll see okay, this P2 is okay. Now we'll come to P1. Okay, for P1 only one time is left. Okay, so we'll come directly here. Okay, now here you can see if remaining is 1. Okay, remaining time is 1, TQ is 2. Whether it is greater than 0? No. That means if it is not greater than 0, this answer can be equal to 0 or less than 0. So it means this remaining time can be equal to tq or it can be lesser than tq. So here we have that remaining time is actually lesser than tq. So that's why this thing will be false and we will come here and we can directly go here. Okay, because when we are coming here, this thing will be true. Okay, so what we are saying, this process, that is P1, can be completed now because either it will be equal to TQ or it will be lesser than TQ. Here it is lesser than TQ, so we are saying okay, just make it completed. How? We are saying current time will be equal to current time plus this remaining time. Remaining time is 1, so we are adding 1. Okay, so current time was 10. Okay, now P will run, and 10 plus 1, 11. So it will be 11 only. So this you have to remember. Here it will not be TQ. Next is remaining time will be now 0 simply. Okay, we cannot do any negative. Okay, we cannot say okay, remaining will be remaining minus TQ. No, we have to make it 0. And after that we will say completed. So it will be completed. Okay, so completed will now be 1. Okay, will now be 1. And then we can find the turnaround time, waiting time using the formulas. Okay, so after that this thing will not run. Okay, we'll add this P1 in this table or not. See, P1 has completed, so it will be executing from the system. So we will not add P1 here. So this thing will not run because pt underscore remaining will not be greater than 0 for this P1. Again, we can go 1 is not equal to 3 and so on. We can keep on repeating the same way. Okay, so I hope now you can run this code by yourself. We have explained everything, this also, this else, this for, and this. Okay, now we have to see this part. What if there are no process inside this queue? Okay, so then can be this situation, and what is the meaning of this situation? Okay, actually for this example we will not come to this part, that is ready queue will always be full. Okay, there will not be any point of time till the completion of all the process that this ready queue will be empty. Okay, but let's see. So to understand this, I have taken this example. So these are the arrival time and these are the bus time. So here you can see first inside this queue P1 will come, right, and it will run for TQ. TQ let's say is 2 milliseconds. So 3 minus 2 it will be 1, right? So that means it is still left to run, right? So at 2, what new process has arrived? New process at 2 is this P2. That means I will be first saying P2 come here, and after this P1 which was executing here, it will be coming here. So in this way you have to put the process. Okay, now next process is P2. So P2 will be running here, right? So P2 will actually complete. Okay, so this is like 0, 0 to 2, 2 to 4. Okay, so at current point of time, the current time is 4. Okay, now P2 will just go. Okay, it will not come here. Now at 4, or you can say till 4, new process has arrived inside this queue or not. Okay, so you can see no new process till 4 has arrived. Okay, this is arriving at 8. So P1 is still inside the queue. P1, this ready queue is not empty, right? So P1 will be going here. Okay, so P1 will run for how much time? It will run just for 1 unit. So 4 to 5. So after this will be over. Okay, now you can see at 5 there are no process. Till 5 there are no process new that are arrived. So PT is arriving at 8. So what will happen? 5 to 8, this CPU will remain idle because this queue is empty. No new process are coming from here. Okay, so 5 to 8 CPU will be idle. Now what will happen when this queue is empty? Because no new process from here and from here have arrived. So what will happen? So at this time we will come here, no new process has arrived. We'll say okay, no new process has arrived inside the queue. That means queue is empty. We will come to this part. Okay, and this is saying okay, if the queue is empty, okay, if the queue is empty, just come here, and what you do, you just scan this whole array again and you just pick any process, any one process whose remaining time is greater than 0. So you can see P3 is the process whose burst time is greater than 0. Okay, so it is starting actually from 1. Here you can see why, because first process will eventually be running on the CPU, or it has run on the CPU. Okay, so we are not scanning that particular process. Okay, we are scanning the other processes. Okay, if there were to be P1 which has to be come inside this queue, then this queue will never be empty. So we are saying, okay, just check, start from the index number 1 only. Okay, there may be process P2 which has arrived, let's say, at 10. Okay, and the current time is 5, so that can be the candidate, or P3 can be candidate, or another can be candidate. But first process we have already executed, or that is not the good candidate. Okay, that's why I'm saying from this. See, these processes have already been completed, so that's why they have not been come inside this queue. Okay, so we'll be saying, okay, P3 is the process which can come here. So okay, add P3. Okay, add P3, mark this visited array for this as true. Okay, that we'll be marking, and then we'll sing break, because we have to just take any one process here. Okay, break. Now queue is full, or you can say queue has at least one process. So we will be again going to this completed loop. We will be going from here to here again. So this way, this part is checking for this thing. Okay, and this code will only run when we have this type of situation, that is CPU idleness. Okay, otherwise this code will not run. Now let's compute the CPU utilization. CPU utilization percentage is length of the total cycle minus the total CPU idle time divided by length of the cycle. So let's see the length of completion cycle, how we can compute. So here we have taken the same example, and this is the Gantt chart for this. So what is the length of the cycle means? It means in what time the total process were completed. So here you can see the process P1 started at 0, and last process was P2 that was completed, and it completed at 16. So 16 minus 0, it means 16. In 16 unit, all processes were completed. For example, if P1 has started at 6, let's say, so 16 minus 6, that is 10. In 10 units, this total processes were completed. Okay, this is the length of the cycle. So how we can compute? So here you can see this 16 is the completion time of the last executing process, and this is P2. And what is this 0? This is the arrival time of the first process. So this is the 0. Okay, now here the main important thing to note is we have sorted the array, or our array of structure, based on the arrival time. So the first process, that is here P1, it is the process which has arrived for the first time, right? So minimum value of the arrival time will be here only, and we want the minimum value. That means we want the arrival time that is minimum. So we can directly find the minimum arrival time from here. That is, you can say that the PS of 0, that is this index dot arrival time, it will be the minimum arrival time. But for the completion time, we cannot say that the last process which is showing into the table, it will be the last executing process on the CPU. Although this is the last process which has come inside the system, but this is not the last executing process. P2 is the last executing process which completed at 16. So what we have to do, we have to actually find the maximum value from this completion time, right? So for this, we have to apply this loop. Okay, so we have to find the completion time from this array 0, 1 to this array of structure. Okay, one by one. So here you can see I have taken the max completion time variable, which is initialized to the minimum value of the system. Okay, int min can be anything. Okay, it depends on system that what is the value of the int underscore min. Now we have started this loop from I equal to 0 to n, and we are checking from this whole 0 to 2. Okay, and we are saying, okay, find the maximum value of the completion time. So here you can see we are saying first completion time is this 11. That is, we are checking from ps of I dot ct, ps of 0 dot ct, ps of 1 dot ct. Okay, so on. So this is simply like how we can find the maximum value from an array. Okay, this is the same type of code. Okay, and this find max is a, like you can say, function. Okay, which is actually comparing that what is maximum between max completion time and this current completion time values. Okay, so in C++ you can just use the max function. Okay, this is already defined. You can use the max function, and it will compute the maximum value between these two values. Okay, so in this way, finally we will get the this 16 inside this max completion time. Now we will come out of this loop and we'll say this 16 minus arrival time of this process. Okay, at 0th index, that is 0. For this example, it will be 16 minus 0, 16. Okay. So we have computed the length of the cycle. Now we have to compute the total idle time so that we can compute the CPU utilization time. So let's see how we can compute the total idle time. So here you can see we have added total idle time line in this if. Okay. So this is the example that we have taken, because in this example we have the idle time from here to here 5 to 8, that is 3 unit of idle time. So here you can see we have taken this total idle time variable, and this will initially be 0. Okay. And we have the another variable is first process, and this is first process is a boolean type variable which can be true or false. So initially it is true. So according to our example, we have the total idle time as 3 unit. So actually our total idle time can be computed in between here. If you want to compute the total idle time between P1 and P2, it will be simply 0, right? So here you can see for the first time when we will run this process, P1 will come, okay, and we'll say, okay, this is like 322. So this is equal to this. These 322 are the remaining values of the burst array. So 3 is equal to 3. So we'll say, okay, just set the start time. This is the start time of the P1. And then we'll say total idle time. So we'll say, okay, if you are the first process, then your idle time will be 0, right? So here you can see before this, you have no process running, right? So the each first process initially was true. So we'll say, okay, the idle time will be added to 0. Here you have to add one line that I have forgotten. That is, you have to make this each first process now as false, because your first process has like started. Okay. So it is like it will be false. So that next time if you come, you should every time go here. Okay. For second, third, fourth, or the any other process. So let's say if you come at this point, this P2, and you started with P2. Okay. So you will say for P2, okay, what is the, you can say burst time, it is 2, remaining time is 2. So both are equal. So you will set the start time. Now total idle time will be, see, it should be 0 now. Why? Because P2 has started at the same time when P1 was completed, right? So you can see, you will come here, you will say is first process equal to true? No, it was false. Okay, last time. So you will come here, you will say start time of P2 is 2. And current time is also 2. 2 minus 2 is 0. 0 will be added. Now let's say current time is now 5. Okay. See, current time, let's say, got incremented from this code 5. Now by this code we are adding the processes inside this queue. Okay. So when we will come at 5, okay, see 5 to 8, in between there will be no process. So your ready queue will be empty, as we have seen in the previous slide, right? So what will happen when we will come here at 5, there will be no process inside the, you can say, this queue. Okay. So it's like a queue will be empty. So now let's assume current time is 5. Say by this code current time is 5. Now this code will be adding the processes inside the queue. So no new process will be coming from here, because from 5 to 8 there is no process. Okay. So this queue will be empty. So this code, what if there are no process into the queue? Okay. So this code, the code that we have just seen here, it will be adding this P3, right? It will be adding P3 inside this queue, so that there is at least one process inside this ready queue. So when we will come here and we'll say, okay, now at t equal to 5, okay, can you tell me what will be the situation? So here what we will do, we will say, okay, for P3, because P3 is the process which will go inside or on the CPU. So for P3, you will say this and this will be equal, because it will be executing for the first time, right? So 2 and 2 will be equal. So we'll set its start time. Now start time will be what? See, current time is 5. Arrival time is 8 for P3. So start time will be 8. Now idle time. Here idle time should be set to 3. Okay, because in between we have to compute this gap. So here you can see its first process is false. So we'll come here. And what is the start time of P3? It is 8. What is the current time? Current time is 5. Okay. So 8 minus 5 will be 3. So total idle time will be 3. Okay, 0 plus equal to 3. So in this way, we have added the total idle time and we got 3. Okay, after this, the total idle time will not change, and finally we will get total idle time as 3. So for this example, what is the length of the cycle? It is 10 minus 0, 10, minus the idle time is 8 minus 5, that we got 3 from here, divided by total length is 10. So it will be 7 upon 10, that is 0.7. And if you want to compute in percentage, we have to multiply by 100. So in the similar way, you can find the CPU utilization for this example. See, for this example, it should be 100%. How? So length of the cycle is 16. What is the total idle time for this? It will be 0. Okay, if we run the same code, we will get 0. Okay, divided by length of the cycle is 16. So it is 16 upon 16, it is 1. And if you want to compute in percentage, you have to multiply it by 100. So it will be 100%. Right? So last thing is how we can compute the throughput. The throughput is the total number of processes completed per unit time. The formula is total number of processes. So what are the total number of processes? In this example, it is 3. Divided by what is the total time period? The total time period or the length cycle is 16 minus 0, that is 16. Okay. So this will come in some 0 point something, so that will be the throughput. So here is our C++ program for the round robin. So here you can see we have used the header files, and the climit header file is for the, you can say, int max and int min macros. Okay, and algorithm header file we are using for the sort function. Okay, and the max function that we are going to use in our program. And you can see we have used the Q header file also, so that we can use the inbuilt Q which is inside the C++. Okay, so here you can see we have the required structure and we have the comparator, we will see later. So here you can see we have used the various variables, right? So vstate is there, is first process, max completion, current time and all. And here you have taken the Q. Okay, so this STL library Q is Q that we have to write as such. Then inside the Q we will be putting the indexes of the various process. That's why I have taken this as the int type. Okay, because indexes will be of int type. And then we have taken the name of the Q. Okay, you can take simple Q or any name of the variable. Okay, here you can see we have taken the arrival time and we have taken the bus time. Okay, and here I have said, okay, I want to print everything till 2 decimal places. So I have used the manipulator and I have used the set precision with fixed. Okay, now after entering arrival time, bus time, we have asked the time quanta, right? Now after that we have sorted the processes based on the arrival time. So here if you see above, I have used the comparator and I have written that please sort the arrival times or sort the processes based on the arrival time. Okay, and in increasing order. Okay, so this comparator is sorting the processes based on the arrival time in increasing order. Okay, now if you go down, so you will see I have first pushed the first process. Okay, the process which is placed at the 0th index after sorting. Okay, this is the first process that I am pushing. After that I am saying, okay, this process has been put inside the queue, so I am saying, okay, make it true. Okay, make it true. And after that, till the time all the process are not completed, so we are doing the same thing that we have seen, okay, in the pseudocode. And this is the end of the while. Okay, so if you go, so here you can see I have used the front and the pop function of this pre-built, or you can say inbuilt Q library inside the STL. So front will be giving me the index of the front process inside the queue. Okay, and pop will be removing the process. Okay, or you can say it will be deleting the you can say process from the queue. Okay, so I have just taken the index of that particular process, and after that I am removing that process from the queue. Okay, and I am saying, okay, do this thing. Okay, so this is the same code, I am not telling you again, and again this is the same code. So here you can see inside this else code, when the process is getting completed, I am computing everything: completion time, turnaround time, waiting time, and response time. Okay, so here you can see I have used the same formulas that we have discussed. The turnaround time will be completion time minus arrival time of that process. Waiting time is turnaround time minus burst time. And response time will be start time minus arrival time. Okay, and this thing we have seen in the SRTF also. And side by side, we are just adding all these completion time, or you can say turnaround time, waiting time, response time, so that we can later on find the averages. Okay, that's why I am computing the sum also. Okay, and here you can see again, here in this I am saying okay, if new process has arrived till the current time in the system, so I am saying if the burst time is greater than 0 and arrival time should be less than current time, and that process should not be visited till now, it should be false only. Okay, then I am saying push that process inside the queue and make it true. Okay, and then I'm saying okay, if the currently executing process should be put inside the queue, if it is greater than 0, then I'm saying okay, the index of the currently executing process should be pushed inside this queue. Okay, so in this way I'm saying all these things, and after that I'm saying if queue is empty, so empty function returns true if the queue is empty. Okay, so if the queue is empty, I'm saying scan the whole processes and just see if any process is having the burst time greater than 0, so push that process, make it true, and then simply break. Okay, and then go again inside the while loop. After while loop is completed, we are computing the all completion time. Okay, or you can say the CPU utilization. Okay, so here we have used the sort function again, and we have sorted the processes based on the PID in increasing order. So here if you see, we have the function comparator PID, and we are comparing based on their PIDs in increasing order. Okay, so why actually we need this sorting again, although we have sorted on the basis of their arrival time in the beginning only, right? So actually the thing is, let's say we have this input data, we have the PID as 0, 1, 2, arrival time and this, and burst time is this. So in the array of structure, we will have this data in this form, right? Now, when we sort this data based on the arrival time in the beginning, then we got this data, right? So here you can see arrival time is 0, 1, 3. So this data, that is this whole box, will go here, right? So 105. Okay, then this one will come here. So 017 will become the second row, and then last row. So here you can see this will be the 0 index, this is 1, this is 2. 0, 1 and 2 index, right? Now here if you see, this will make this array of structure. Okay, so at 0th position now we have the 105, at 1th we have 017, and at the second index we have the 234, right? Now we can print this data also. See, we will have the completion time, we will have the turnaround time associated with each of the things. Okay, we will have the data inside these boxes, so we can print this data also. But let's say if we want to print the data in this way, okay, that means the original way in which we have the PID 0 process in the 0th row, then the first PID person or the process in the second row, then the next PID process in the next row. So in this way, if we want to print the data, then we need to sort this data again. But in what order? We have to sort this data based on the PIDs. Okay, so we have to sort the data in the increasing order of the PID, so that this PID becomes 0, 1, 2. Okay, so just for the output purpose, in a better way, we are just sorting this data again on the PID. Otherwise, if we do not sort second time, then also our data will be correct and our output will be correct. So after this sorting is done, we are just printing the data in the tabular form. Okay, and we are printing everything like arrival time, burst time, completion, turnaround time, and so on. And at last we are printing the averages, throughput, and the CPU utilization. So now let's run this code and see. Let's say we have 3 processes, and I will run on the same example 0, 1, 3. Time quanta will be 2. Okay, so let me make it large. So this is the table that we were checking. This is the completion time, turnaround time, waiting time, and response time. And after that we have got everything, averages and throughput and the CPU utilization. For our example, the CPU utilization was 100. Okay, so you can run for the another example that we have discussed, for which idle time was 3. So for that, CPU utilization will come as 70%. So you can just run it by yourself. I have provided this code in the video description below as the GitHub link, so you can run this code. Okay, I hope you have understood that how we have implemented the round robin algorithm using the C++ program. So if you have any question, comment, suggestion, please write down into the comment box. If you have not understood anything, please write down into the comment box. And if you like the video, please like and share this video among your friends also, and subscribe the channel and press the bell icon for further notification. See you in the next video. Till then, goodbye.